Just so it works. Yeah, right. This is not gaming, so. Is it back? Can you hear me again? I think I'm just not going to care all that much for these lectures for now. I'm gonna encode them as I need them. Let's just see. So let's start with, if we check out the layouts, let's start with, let's do proper name, for example. First, a general proper name. We want to do that. So let's do that. So it's probably token parsing M, and then we want to make that a token parser of p dot proper name, like that. And now this does is map the proper name constructor over the uname parser. Now, what's going on here? So what we need to do is we need to replicate the uname parser basically, and I know that that one is in Lexer. So let's look at uname here. So we want that parser. Again, this one is a token parsing parser. Oh, what was that? A string. I don't need the brackets actually. It's not PureScript. So token parsing of M is supposed to give us a string. Well, it turns out I want text instead. I don't want to use string anymore all the time. So what we need to do is because the PureScript constructor still wants a string, we need to do that basically. Okay. So, what's the type of token? MA. I don't think we actually give a shit. Oh, we definitely need to move that function over. Why is this broken? This is so annoying. God. So what we need to do is we need to take the valid uname function from over here. Let's see if we can copy that. Wait, so what's the valid uname? Everything is a valid uname that does not contain what? That's all? Oh god. Okay, so again, we don't want any string functions in here, so we're gonna make this a text function. And then we probably want text.notLM. Is that a thing? Okay, it's not. Let's look at the text library in that case. Text, let's go. There's probably something like a contains no. What is there though? Is there an elem? Oh, there's a find. So maybe we need to do find. Okay. Wait, is lm defined? Let's try. Maybe we can just use lm because it's defined in terms of foldable. Yeah, it is. So we can just use that. That's nice. Okay. Let's try this again. So this expects to run on a... I think this expects to run on a token again. Yeah, I think so. It's annoying as hell. So probably we need to look into the lexer again and just see how we actually happen to get a uname token. So let's look for that. So what is a uname? Uname. Not sure where's this token function defined? Is this from parsec actually? No, it's written. Okay. It's defined right here. Okay, let's see if we can find something like a token parser here. So there's token parsing. Does it have things like braces? I think so. It does, right? I think it does. So this is char parsing. Huh. Yeah, so the idea is that we could lex before we do the parsing and then parse the tokens that we get, or we could actually intertwine the two. I'd like to see if trifecta actually has facilities to do that. So let's look at this. Parser rendering delta combinators. Yeah, so it doesn't really look like we're supposed to prepend any of that. Right. Yeah, so let's just not do that then, I guess. Let's check out how to parse a uname. Where does that happen? What does the lexing actually do? How do we happen to get that token? That's pretty printing. Where does that actually happen? Sounds like this. Yeah, there we go. So this is the token parser. So where's the uname thing? It's over here. Parse uname. So what's a uname? Guard. Valid module name. I think guard is from plus. Yeah, takes a bool and returns a parser. A result inside the parser monet. Let's go here. Valid module name. A valid module name is anything that does not contain an underscore. I don't think that's correct. I think we need there to be a capital character at the start. But maybe we've got a lower name first. Yeah, so probably this already takes away all the identifiers that start with a low level lowercase character. Let's look at ident start. Yeah, so it's either a lower or it's one of underscore, which is the same as char underscore. Right. I mean, we probably still want all of these. We just don't want to prepend the full lexing stage to our parsing. I think so. So what we do, we guard that this thing is not an invalid module name. And then we wait, how does this bracket? Does this bracket like this? Or does it bracket like this? No, these two are bracketed together. Okay. Okay, so either so it's either a module name followed by a dot, or it's just a module name, I suppose. Or parse uname. There we go. That's parse uname. So it starts with an upper letter and then it takes many identifier letters. Oh, I see. So in the lexing, we throw away the dots. And then when parsing, we just expect a bunch of unames, one after another, I suppose. That sounds like what's going on here. So we kind of need to inline these lexing functions into our definitions. Okay. So how do we actually parse a uname? What we're going to do... I really hate this. What we're going to do is we're going to parse a uname. And that one I can port. Like this. Right, so let's actually parse a uname. Right, and what this is we might need char parsing actually rather than token parsing. We'll see in a second. So char parsing, I think. And this is supposed to be a parser of string. Does that work? Sorry, parser of text. I don't want any strings anymore. Okay, so we want an upper, and then we want many ident letters. Oh, I see, and this does of course not work. So let us see what we can do here. There's probably something. There's probably a token parsing thingy. So there's a symbol or text symbol. Let's see what that is. Suppose, yeah, you still need the token function. And you don't get to do anything. Yeah, so the text symbol one requires you to pass in the symbol that's supposed to be parsed. Okay, so this is the a dot parser. we want something that parses every char or something. Let's look for these. Character char. No, we don't want that one. Okay, so let's look. I think what we want is not parser token, but instead parser char. Yeah, and then we've got upper and lower and stuff like that. So we've got upper, and then we can use many ident letters. And if I remember that correctly, an ident letter was any character that was not a none of and then what we pass, I think underscore, I think that was how that actually was defined. And then, well, uname is not exported apparently. So how about you just fuck yourself? We're just not gonna wrap that. It's just gonna be a string. Right. Oh, yeah, and that's an M actually. So let's see. Yeah, now that's not gonna work anymore. Instead we want text.const here. And this is of course an array of characters at this point, so we need to transform that into a text. We need to map that instead. And bracket it correctly. There we go. Now, okay, so it's not actually foldable, apparently. We're going to take a look at this in a second. So I think what we want is actually M0 or fail right here with proper name. We'll take a look on that in a second. So we can use not char for this one. It's probably going to be a bit more efficient. Okay. Huh. So let's see. How do you use the token parser again? You go. I'm going to take a look at this again one more time. Right. So token P first applies parser P and then the whitespace parser, return the value of P. Every lexical token is defined using token this way parser. So, okay. So what we do is we apply this one. And then what we do is we say token parse uname. Right. And then we want to make sure that we actually fulfill this valid uname thingy, so we do not accept these in there. So I don't really understand that uname thingy. What's that supposed to be? Is that supposed to be any identifier that starts with a capital character, and then module names also are not allowed to include these, apparently. Yeah. So what we're gonna do is we're gonna parse uname, but we need to make sure that this thing satisfies something. So let's look at, I think that's in here. I think that's the satisfy, but that's only a single one. But we want to make sure that a piece of text satisfies that. Right. So we want to guard. Alright. So what I want to do is guard this thing with valid uname. Does that make sense? Again, let's parse uname. What's the problem here again? Yeah. How do we go about that? Let's do it the naive way first, and then we'll figure out how to do it the nice way. So what I'm going to do, I'm going to use Haskell, so I need to do that. I'm going to do uname. And this is broken, what the fuck? I hate it when Haskell mode does that, and I have no idea why. Whatever. So we're gonna guard against UN. In case it's fine, we're gonna say pure UN. Now, we're gonna guard against valid uname. And then we also apparently need to specify that M is a monad. Does that work now? We also need to say that this is a monad. Okay, now we're almost there apparently, and now we just need to make sure that we find the right text function to make sure that all the characters satisfy something. It's a condition, basically. So that would be this one. So what we're looking for, we don't want any character to be this. So not any equal to that. I want this to be text.any. Like that. There we go. Okay, so that compiles, apparently. So, let's try to actually parse a proper name, I suppose. So we can put that in here. We can say parse parse proper name, right? We just call it proper name, okay. So just proper name. So if we now do p prelude, that gives us the prelude. Let's do main.main. That gives us main.main. Let's do main underscore main. That's supposed to be okay. Close. That's one thing that the trifecta library does. It's quite nice. It gives us these nice errors. So right there, write the underscore. That's the problem. That doesn't work. And we also can't do this. Oh, interesting. Unspecified error. Does that work? Unspecified error. So maybe that's what happens. Yeah, that's probably what happens if we fail that guard. It's just we lose the error information basically. So I think we're gonna need to look up how to do errors in trifecta. So what's the combinations that we have? I think what we look for, maybe that's in here though. Let's look for the combinations in here. I think we're looking for something like that one. Give a parser a name. So does that work? So how am I supposed to do that actually? How do I fail these properly? Right, because yeah, that would be strange. So maybe I just really need to do if here. Then pure un, and else, and then maybe I can give a better error message here. Does that work? Unexpected, and now I'll pass unexpected a backslash. Oh wait, that's not a backslash. Like that. Does that work? Let's try it again. Yeah, there we go. And now we get an unexpected backslash. But it still cannot give us the right error message. Yeah, so that would be text.trifecta, I think, where we actually do that. Where we really raise an error. So does that work? Can I raise an error here? And I need to do an error. Does that work? Well, let's try that. Raise error. Now how can I create an error? Failed. Like that. Does that work? So I can say module names cannot include backticks. Does that work? No. Oh, because it's raised error. Error. And now we also need arable, whatever that is. Alright, and we also need arable here. Maybe we should soonish. Okay. Maybe we should come up with a proper synonym for these soonish. So let's see if we now get the correct error message. Nope. Well, I mean, we get this here. Oh yeah, well. Because the error doesn't happen at the right point, basically. I think we really want two different parsers for module names and for upper name strings. I don't think we want this. Yeah, let's do that. So module name token, basically what we want, right? And that's char parsing to text, right? And then what that is going to be that. And then we do none of. Right, and then we do none of underscore or backslash. No, wait, it's not supposed to be that thing. Right. And then that's an M. And so what we're going to do instead is we're going to say token, and we're going to say highlight, because that's, well, we're not going to do that now. Okay, well, let's just not do that. And then instead we say module name token. Okay, so let's do that again. And now that works, which is kind of sad, because that totally wasn't supposed to work. So wait, what's the problem with me? Okay, so we want many, none of, underscore, or what's that? What's the problem with that? Interesting. I'll actually just close the window for a second. So, what's going on here? I think we had it with the none of. So probably, how does that now work? So we want many, where none of them is part of this list. So why does this not work again? What about an underscore? That didn't work. What about that? That didn't work. It still succeeds parsing this one, though. So what's the problem here? None of. It's a char set thing. Huh. Can I do that? Underscore or that one? Does that work? Or does it not? Does it fail with type inference? No, probably doesn't. It does actually work. And now it fails at the right place. Okay. So hello would be a proper module name. Okay. So So, does this actually have any idea of positioning? Seems a little strange. There's no notion of position. Because I want to... Because I really want to be able to give positions, like positioning information for the stuff that I parsed. Right? So maybe that's in Delta? Does that sound like a thing? Probably not. All of this stuff is about rendering. Is that rope? No. Parser combinators needs the ability to parse characters. There we go. How do I parse and display source code positions? And that would be position probably. So let's look at position. Retrieve the current position as delta. Well, delta kind of sucks. There's columns, tabs, lines, whatever that is. Man, that's kind of hard because the documentation is so sparse. I'd like to see a few examples. Example project linked here. Okay, so let's see what we got. Getcom parser. That's a bunch of characters. A few like cute parser thingies. That's nowhere close whatever that is probably copied from somewhere. Was that supposed to be? Oh wait, I looked at that types, and that's just boring. So that's not an example. There's nothing in there. So iters is written with. Let's look at that. If iters really is written, and like the parser is written with trifecta, I'm totally going to use that as an example. So if I look at Cabal, do I find trifecta somewhere in here? Yes, there's trifecta. Okay, so let's look at iters. Sounds like this might be where we want to go, and then we want to go to parser. Okay. Is there a top-level parser module? There is. Is there something like Lexer? No. Okay, so let's look at parser. Oh, it's only 1,900 lines. Okay, maybe I want to clone the repo then, so that I can look at it in a proper editor. Yeah, let's do that. Okay, so let's do that. So let's git clone that. Okay. So, let's see. What's going on? Whatever. I don't have any of these. Fuck off. There's some quality shit post there, right there. Okay, so as this is still downloading, I'm gonna let this continue downloading, and I'll be right back. Alright, I am back. Let's just set up a cup of tea. Just need to set an alarm. There we go. So, finished. Nice. So let's look at the parser.hs file now. Okay, so this wants to reinstall all these things. All these things. So, while we're at it, while this is building on the side, we can take a look at a few other packages that they are using. Are they using indentation? No. So how do they do indentation in trifecta actually? Interesting. Okay, so what do they have? That's a bunch of pretty printing down here. Okay. Okay, so they've got they specified a grammar for the stuff that they do. Okay, so they've got a module header parser. So, do they not use? I want to see how they. Where do they actually use delta? I'm sure they do somewhere. Okay. So modules do not take arguments. Docs, optional document. Reserved HL. I shouldn't have asked for the type of that. So I'm just gonna search for that thing. Parser reserved identifier highlighting its span as a keyword. So they are using the highlighting thing. That's very interesting to me because I want to do that too. So let's look at the address parser. What is that defined? Is that a new type? New type address parser? No, it's not. Is it maybe just a type? Don't want to do that. Fuck off. So where's address parser defined? Type address parser? Yes. Okay. So what's the I state? Still building, of course. So what's I state again? So where is that defined? So I state, is that type I state? No, it doesn't look like it. Maybe data I state. Data I state. There we go. Holy crap. The global state used in the address monad. What? What kind of thing is that? Don't tell me that's a good piece of code. What? Okay, interesting. So there's stuff like elaborating thingies in here, which totally is for the type checker and not for the parser at all. And this, however, is totally parser states. Oh god. I'm gonna What the fuck? Who does that? Holy fuck. What the fuck? What? Okay, maybe that's what that looks like, apparently. Oh, seems like my tea is finished. I'll be right back. Was that called pedestrial? I think so. Okay, so what? Okay, so this is constraint kind. So monadic parsing is delta parsing, look ahead parsing, token parsing, and monad. Why is there no char parsing in there, for example? Are they lexing somewhere else? Sounds like that. And then there's the highlight parser, and that's really interesting to me. That's very interesting to me, because I want to do that as well. So maybe I need to look at their implementation for token parsing. That's here. Where do they overwrite the highlighting? Are they not? Wait, that one looks interesting. Get FC. Get file position as FC. I want to know what FC is really quickly. Is something happening? Yeah, something is happening. Huh. That T is really not all that great, gotta admit. Yeah. Okay, so there's two JSON going on. What's going on here? Oh, whatever. I'll just keep that around. Oh, don't want to do that. Okay, so this is still compiling apparently. So I'm just gonna continue searching for these things, I guess. Data FC probably. There is. What's that module TT? The core language. Full dependent types. Pattern matching letter binding. Why is the intermediate language? Why does the intermediate language have source code annotations? I'm not really sure about that. No idea what that is. Get the largest span containing the two FCs. The largest, probably the most minimal one. Right. What? What? What's going on there? What? Okay, so that's a bunch of source code stuff, so source position stuff. So I could totally see myself wanting to use that. What's this? Down there, me down. Output annotations for pretty because I don't have any of that. Text formatting output. Don't need any of that. Type dates in meta or something like that. I'm gonna need something like that for the highlighting, probably. If I were to ever do. Okay, so this is just source code positions FC. So how do you grab the line num and the column number? Where's that coming from? Line number. Okay, that needs a delta though. Let's look at that one. Can I not open that? Is there some... Whatever. I think I can click on it and open it up. Yeah, so that works. File position is a span. No idea what's going on here. Yeah, so whatever. So how exactly do they actually get the column number? So this just returns a fixed value, right? No, wait, this needs to be passed a delta, and that delta is gotten by actually accessing the position, I think. So that's that. And then, yeah, but that's not a span, that's just a simple FC. That's not spanning anything, basically. It's just the same position twice. Okay. Okay, so they've got an indentation stack going on. They're not using the indentation thingy that I found, so I might reuse that. And then they've got this thing going on. Okay. Yeah, so all that stuff is indentation. Maybe I need to roll out my own as well, but okay, so I want to see how they extract the highlighting information actually. That's really interesting to me. So highlighting. Okay, so where do they extract the highlighting? Maybe I need to check that out. What's going on? Highlighting. Something is broken here. So Idris, do they have a highlighting file? No. Maybe something in here? No. Colors, maybe that's the thing. Colors. That's a theme. I'm interested in the... Where do they extract the positions though? Really interested in that. Output, proof search, reflection, transform. unliterate transforms. Who calls was that? Okay, never mind. I don't give a shit. So, probably still somewhere in the parser, apparently. So it looks like they are using the highlighting machinery from trifecta, but I can't see where they actually insert or extract that. So they do have this thing going on, which is a reserved FC, which gets the position that we're looking at, and then it does reserved, which is reserved with Idris style. Yeah, sure. And that's a span, right? But it does not, so it does the highlighting apparently. Alright. Oh, so maybe they do something in here. Highlight P. Yes, this looks like it. They maintain a stack of highlights, and that has a span with an output annotation, where output annotation was exactly this data. Okay, so they maintain that on the side apparently. And Idris parser does have access to the state, if I remember that. Yeah, exactly. That's just Idris inner parser, which is just a parser. But this actually has access to the I state. Where's parstring coming from? That's from, yeah, that's from trifecta actually. So, maybe I can actually just put that to use and just do the highlighting thing, because I really wanted to do that the entire time anyway. So I'll just take this thing for a second. Now I'll go back in here. And just see if I can do that. So let's write a file highlight.hs. Yeah, that's module highlight where, and now I want to rename these things. So that's highlighter. That's the highlight state, so HL state basically. And okay, so what does this have? This has a inner parser, so let's call that HL inner parser. Right. It's the HL inner parser. Run inner parser, fine. Well, I should really rename these to HL inner parser. Right. Now I need to rename Idris parser to highlighter. Okay. And now, of course, I need to add a bunch of stuff. So I need to do that. Like this. If min version base. Well, yeah, my version is probably min base, so I'll just add an overlapping, I suppose. Maybe. No idea. So I'll import trifecta. I'll just import that stuff. See what we end up with. And then I'll also import. That don't work. PM. What's going on? PMP.prelude. Now, apparently that's not defined. Yeah, well, I'm gonna define that. So HL state, let's say that HL state has highlights, which has type array FC HL, whatever that is. I'll define these two in a second. So I'll just say FC is equal to FC. I'll do the same for HL. Okay, so what's the problem? Mark parsing delta. Yeah, delta is probably somewhere inside trifecta. I think it's trifecta delta actually. Yeah, it is. So now that's back. Let's look at parsing. Where's that? Probably text parser. Look at. Huh? Look at. There you go. And now let's add data kinds and standalone deriving. So state T. State T is in control monad state, I suppose. Import control.monad.state. But I really expect that to be exposed from the prelude actually, so it's a little strange. What's the problem exactly? Is it really not just not there? So whatever that is, I don't give a shit. But why is state T not exposed? Can't expect that to be whatever. Monad.state. And now I'm gonna need to import that. So I'll go into the cabal file. Say, hey, I need transformers. Let's restart in Taro here to get the new arrows basically. What's the next one? Come on. Oh wait. I said transformers when I meant MTL. Right. And now I restart. So it looks like now we actually get down to the white space parsers, which is nice. I'll just keep stealing stuff, I suppose. So why not? Where's the parser gone? Where was that defined again? Was that somewhere here? Let's look at the parser again. Yeah, that's idris parser. What is idris parser defined again? It's in helpers. Why is that? Why would that be in helpers? That's stupid. Okay, so where's simple white space defined? I think we want all the white space. Yeah, I'll just take that one. So let's just copy that over. Oh well, it's nice if that helped. So, where's the space defined? His space, where's that coming from? Maybe from here. Maybe this one. Yeah, it's from there to the char. Right, so next one. Fuck string, by the way, we're gonna use byte string there in a second now. So last token span seems to be a piece of code, piece of state inside the idris state, so the HL state in this case. So we need to add that here. We're gonna do that in a second. And we could just do that right now. So that's an FC. Right. So what's the next error? Single line comment. We need to do that. And multi-line comment. Okay, so we need these two. Single line comment and multi-line comment. We need both. And we're gonna throw away all the documentation. Holy crap, that's a bunch of code. We can probably make that a bit simpler for PureScript, because that's how you do comments in idris apparently. Whatever. What's the problem? Fuck off. Okay. Yeah, so we don't want, so we need to hide try from here, apparently. As text. Okay, that's an array of characters. What's that? Is end of line probably in here again? No. So where is EOL defined? Let's look. There you go. Okay. That's simple enough. What's the next one? End of line. Yeah, we want that one. Where's that coming from? Text parser combinators. Wait, we do have that. So what's the problem again? Oh, EOL, but it's end of line. Oh yeah. Now I see. So I want to add that one. So I suppose I could put on a bit of music, as long as there's no copyright on it. I think If I got that right, it's fine. Play FX Twin. So in case you want some, I can put some music on. I'll just do that actually. I think it's nice to have a bit of music. Maybe we don't need to get started with super crazy bullshit. That one is nice. So I'm gonna put on some music. Let me know if it's too loud or if it's overshadowing my voice too much. Okay. Where's get FC again? Down there. Let's do that. Oh god, what's going on here? Whatever all that is, we're just gonna say file in here. Press. Okay, what's file name? Right. Fuck you. And now we need to know column num. Where's that coming from? That's probably inside the delta thing. Let's look at it. Where's that delta? No. Parser, no. Position. Right, so we need that one. Text trifecta connectors. Do not have that one. Yeah, the text trifecta connectors. Apparently, line num is like that. File name is like that. Okay, let's just grab all of these. I'm gonna make that an array of char, do that as well, just so we unlock that. Just gonna make that a byte string. Well, put that in there. There we go. Now we only got 1 hour left. That one. That's the next one. Constraint finds. Yeah, about that. What's it called now? Illegal instance declaration. Use types in instances. Holy crap, whatever that is. Sure. That don't work apparently. So types. Oh wait, no, it did. There's types in there. It's right there. I'll be right back. I'm flexible. Format this at least. Try generalize new type deriving. Yeah, we have that. Generalize new type deriving. Next up, FC. Yeah, that needs some proper. This one is wrong. And then the second. Yeah, I'll be right back. Maybe I'll actually turn off the stream and maybe I'll come back later. I'm not sure yet. Anyway, thanks for watching. It was maybe a bit boring, but apparently at least my voice was soothing to you, so at least there's that.